Hi, I am Anuj Majumdar. When building non-deterministic pipelines, like an Amazon competitor selector, the hardest part isn't the code. It's debugging why the system made a specific decision. I built X-Ray to move beyond simple logs and provide a decision funnel for complex workflows, firing up the MVP based on Next.js. Here is our dashboard. For the sake of this particular demo, I've created 20 test cases belonging to 5 product categories mentioned over here and 4 test cases each. Then I have a run random button and run all test cases button. If I click on the run random button, I can see how the output will look like. We will have a uniquely generated execution ID, the workflow category, status, the number of steps it reached down to, duration, and the timestamp. Running all the test cases to deep dive further. First, looking at a happy test case. Let me move towards this, the smartwatches category, which move till the step 5, and I'll break down these steps. Okay, so now I have a particular use case of a particular log. So in this use case, for the category smartwatches, the first step is an LLM step where keywords are generated based on some input context. So for example, I give this particular input and the output is a result from the LLM giving me the relevant keywords. And the same has been given in the reasoning context part of X-ray. The next step is an API, which is a search API, a simple fetch which will use these keywords from the previous step and accordingly give us a catalog of the items that are relevant to this. Third step is a filtering step based on business filters, and from here we can see some drops getting started. So the reason context is again given. The price range is one of the contexts, the rating threshold and the review count is given, and the USP of X-ray is to provide the exact reason for the decision for the drop. So in this case, these two brands got dropped because the price point was too low according to the direct competitor. We're left with 3 of them. Next, moving to the next one where we have the LLM relevance evaluation, which evaluates based on false positives. And as you can see over here, it is clearly mentioned that this particular brand got dropped because the product is a false positive. It is a different use case or it is a category mismatch and a low relevance score is populated corresponding to it, whereas the other two have passed and a semantic similarity score has been populated. This is again an LLM step. And finally, coming to the ranking step, which is the 5th step, which calculates a composite score based on relevance, reviews, ratings, and price. And the one with a higher composite score is passed on as a result. So this is our happy use case where all the 5 steps get executed perfectly. Now moving on, how X-ray helps us with the test cases that are failing. So I'll pick up this one which failed at step 4. Again, the overall schema remains the same where we are following this ladder of steps, generating search keywords using the LLM, moving to retrieving candidates based on the search API, followed by applying business filters, and again, all of the decisions have been given to us in a step-by-step manner so it becomes easier for the developer to debug. Here is our culprit. The 4th step, LLM relevance evaluation failed because of this particular error, which was LLM evaluation API quota exceeded, and the reasoning context behind this is also given. So this will help the developer to debug a system and hence improve it so that this may be minimizes in future. In this way, X-ray provides a unique value as compared to the traditional logs where we simply get a failure message. Moving to a different test case now, maybe the one where it failed at step 3 for smartwatches. Again, the pipeline remains the same, generates search keywords. This was successfully done using the LLM step, then retrieving candidates via the API. Yes, over here you can see that all of the 5 retrieved results got dropped and the exact reason is also given. Business rules were too restrictive, Hence, all candidates were eliminated, giving us a zero count at the end. So, this is again how X-ray is able to X-ray into the logs and help developers save time in debugging. Going to a test case which failed at maybe two steps. Again, clicking over here. Keywords were generated successfully, but we were not able to retrieve candidates because of maybe a database connection error in this case. Hence, accordingly, we are able to debug this. And going to, I think, the worst case, which is failing at step 1. As you can see, the first step, which is to generate search keywords based on LLM token, the LLM token limit has exceeded, and hence the search has failed at this first step. Now, moving to the X-ray system architecture. The SDK layer is a managed execution. The step function acts as a wrapper around business logic. It starts a timer, opens an error boundary, and provides a scoped logger to the developer. Context is captured. It collects three distinct types of data: input output, the raw data for technical debugging; reasoning, the chain of thought for logic debugging; evaluations, the decision funnel for dataset debugging. Then comes the persistence layer. It is an isomorphic dispatch. When the submit method is called, the SDK checks its environment. If it's on the server, it imports the storage singleton directly to avoid network overhead. If it's on the client, it dispatches a post request to the internal API. Unified memory store, a simple central array that holds the trace objects during the server's lifecycle. The UI layer, which is reactive polling. The front end fetches the trace list from the API and filters for the specific execution. Timeline rendering is done. The UI iterates through the steps, dynamically changing colors and icons based on the status and type. LLM API, filter, etc. for each of the steps. The decision funnel methodology, one of the most unique parts of this architecture, is how I handle filtering logic. Instead of just returning a filtered array, the architecture captures the fate of every item that entered the function. 100% entry of the candidates are logged. The filter gate, each item is passed through a logic check. Evaluation log, even if an item fails, its metadata and the reason for failure are pushed to the trace. Result, the UI uses this to build the outcome table, allowing us to see exactly where our data leaked out of the pipeline. Now I'll move to some limitations for this particular MVP. It is an in-memory store. Traces reset when the server restarts. It has linearity. Visualizations assume a sequential flow. Parallel step execution is not yet rendered graphically. And it is now working on mocked services. External APIs, LLM/search are simulated to ensure a consistent review experience without requiring API keys. Future improvements can be to integrate this with Postgres or JSONB for long-term queryability and regression testing. Replay engine allowing developers to rerun a specific step with modified logic directly from the UI. Trace drifting, side-by-side comparison of two executions to identify a winner change between versions. So that's from my side. Feel free to ask any other questions that you have, and thank you so much for watching.